Hi, and welcome to 5 Minute Physics. This video is about energy resources, and we're going to be focusing on fossil fuels. Energy is an absolute essential for everything we do in life, whether that's just lighting a fire to keep warm, whether that's using transport like cars, motorbikes, aircraft, or whether it's charging your phone or making a cup of tea. We actually need an enormous amount of energy every day. We normally get our energy via electricity, but electricity isn't a type of energy, it's just a way of moving it around. So where does the energy that's transferred to our kettle or to our phone or our laptop, where does that come from originally? Well, we have a range of energy sources that we can use. We harvest the energy from these and use that to generate electricity. We can split up these energy resources into different categories. So at the top there, we've got what we call the fossil fuels, coal, oil and natural gas. And then we've got the renewable energy sources. These are becoming more and more popular for reasons we'll think about in a while. And then finally we've got nuclear energy. Nuclear power stations, things like nuclear fission, and maybe in the future nuclear fusion, although that's not an option at the moment. So the fossil fuels. You're probably well familiar with these. We've got oil, we've got coal, and we've got natural gas. Now all of these three are leftovers, they're remnants of long dead plants and animals. Over enormous amounts of time, and given the right conditions, which usually involve a lot of pressure and often a lot of heat, then the remains of these organisms are transferred into what we'd recognise today as coal, oil and gas. Now, there are some serious pros for fossil fuels, which is why they've been so popular for so long. Firstly, they are reliable. We can stockpile large amounts of these fuels, and provided we've got enough of the fuel, we can always use them to light or warm our homes or to charge our equipment, whatever we need that energy for. We're never going to have to depend on weather conditions that we can't predict or can't control. Secondly, because the technology's been around a long time, it's relatively cheap to build power stations that use these, and the technology is pretty well understood. There's not enormous changes being made now in how we use these fuels. Slight improvements being made, but nothing dramatic. There are some serious downsides to these three though. Number one, they're non-renewable. As you've probably heard, we are running out of all three of these energy resources. The trouble is they are not being produced in any great quantity anymore, so we're using them up faster than we are replacing them. That means sooner or later they'll all be gone. Secondly, and perhaps more importantly still, then they produce greenhouse gases when we burn them, most notably carbon dioxide. And greenhouse gases basically trap heat inside the atmosphere. They stop the Earth cooling down as much as it should, and that warms up the whole of the Earth's atmosphere and leads to things like climate change and of course global warming. To really understand how fossil fuels are used in power stations, you need to understand what turbines are and how they work. You're not likely to be directly asked about this in an exam, but it is an important bit of base knowledge. A turbine is basically just a set of blades mounted onto an axle. And it's arranged so that when a fluid like air or water or steam passes over the blades, it makes the blades rotate. You can use those spinning blades to drive a generator and use that generator to of course generate electricity. So essentially, turbines harvest energy from the kinetic store of a moving fluid. So this arrangement is what we call a thermal power station, and we'd use a thermal power station in order to extract the energy from fossil fuels to generate electricity. We could also use other fuels in one of these as well. So the basic principle is fairly straightforward. Over on the left hand side we have a furnace, and in that we would burn our coal, our oil or our gas. Just above the furnace is a tank, and that tank contains water, and when the water's heated and boiled it turns into steam. Now steam takes up far greater volume than the same mass of liquid water, and so it causes an expansion and the steam pushes outwards, and there's a series of pipes that lead to some turbines. And as the steam pushes through those, it makes the turbines spin, and connected to the turbines is a generator. So the spinning turbines drive the generator and electricity is generated. The leftover steam is then sent to a cooling tower where it's condensed back into liquid water, although it'll still be quite hot, and then we use that hot water to go back into the tank above the furnace, and that saves wasting the energy that we've supplied to the water to warm it up. It makes the whole process much more efficient. The electricity that's been generated will go through a step-up transformer, which will increase the voltage, the potential difference, and decrease the current, and that will allow it to be transported more efficiently across the national grid. So, to summarise, we can use turbines to extract energy from the kinetic store of a moving fluid like water or like steam or indeed like air. Fossil fuels are reliable, they're relatively cheap, and we are pretty good at making power stations that use them. But on the downside, they do produce greenhouse gases when they're burnt, most notably carbon dioxide, and they are non-renewable, so they're going to run out fairly soon. Thanks for watching this 5-minute physics video. Please subscribe or check out our other videos explaining GCSE physics in simple 5-minute lessons. Bye for now.